Hey everybody, we are going to take a look at this lesson right here, sorry about all the switching up and everything. Still trying to figure out all these new tech tools and things I'm learning about and working on while we all go through this, our quarantine and everything. So, next subject we're looking at here is called slope. And slope is a really interesting concept because it's when I think about it as a math teacher, to me it seems like something that should be kind of like really easy for kids to pick up on, but for some reason it's not. And so what I want to try and do is I want to try to break this down in as intuitive a way as possible for you, so that even though some of the math might get a little hard and at times weird, it's still you understand the basic concept of what slope is and you have an idea of how to find it, so it's not just like some weird thing that sort of materializes out of nowhere. So what slope is a concept where we can quantify how steeply pitched something is, that and what kind of an angle it's on. So for example, all right, it says what is it and what does it have to do with math? Well, it has everything to do with math because there's so many real world applications where we need to find a way where we can mathematically explain the difference between two different things that maybe are both pitched a certain way or leaning a certain way, but one's leaning more than the other. All right, so I'm going to show you exactly what I'm talking about here. So take a look at this, I call it a real world application. We're looking at a bunch of different roofs. All right, and if any of you has been near any of these different kinds of homes here, basically the way I think about it is if I had to do something on somebody's roof, if I had to go up on their roof and maybe work on a chimney or replace a couple shingles or get a frisbee that got thrown up there, whatever, what roof of these that are shown, right? So we've got, all these here, which one would I want to go on? And, I've been on a lot of shallow roofs and I've been on a lot of really steep roofs. And I'll tell you right now that if you're looking at this roof that has a 12-12 pitch, you don't want to be on that roof because it's really easy to fall off a roof like that. Same thing with one like this. But as the first numbers get smaller and lower, the roofs get more and more shallow. And, then you get to this one, which is, it's not flat, obviously, but it doesn't have a lot of pitch on it. So, you could sit up there all day if you had to. So the real world application of this is in things, especially with construction, and there's all kinds of other things, and I'll show you some other examples. They need to come up with a way to numerically describe how steep they need something. All right, so here's another example of that. You got a wheelchair ramp, okay? Well, wheelchair ramps have to be a certain, they have to go up at a certain angle, because if they go up too much, right, that angle right there, if it's too steep, somebody who's on their own in a wheelchair is going to have a really hard time getting up that, because a wheelchair can't go up something that's like this steep, but it can go up something that's like that. So that's why wheelchair ramps are always kind of longer and usually do something called a switchback, where they do that thing right there, because that's just going straight up like you see the stairs here. A wheelchair would never be able to make that. It's too steep. All right? So that's another real world application of it. And then even just looking at these stairs, how do I know the stairs are the right steepness and aren't too steep or too shallow? Because these are things that we don't think about, but they all have real applications. So there's one other example I want to show you, and something you don't think about, like sidewalks, right? And this shows a sidewalk. I got this from like some company that works on concrete. I think they do mud jacking. And they're showing you a sidewalk here that it's the same sidewalk. It's before and after shot. Here is what it was doing, and it was pitched. In other words, the sidewalk was leaning so that it was going that way. Well, why is that a problem? Well, if it rains, the water hits this and then it flows that way. Well, you don't want that because it's going to go in your basement. But what they do is they try to pitch everything going away from a house so that when the water hits, it goes the opposite and away from it, and then when it gets into the grass, it gets absorbed by the ground. So, maybe a little more construction and home improvement thinking here than you bargained for. But my main point is that slope is a concept that is used, and there's a way to numerically quantify it, okay? And by quantifying, I mean put numbers to it. So it says, how do we quantify this? Well, you see here they got 212 pitch, 412 pitch, 512 pitch. Well, if I look at this one right here, right in the middle, it says 712 pitch. What that means, all right, and then we're going to look at a real slope thing, is for every 12 inches that it goes this way, it goes up 7 inches. So if you went over 3 feet this way, this would go up 7 times 3. This would go up 21 inches. Okay, so that's what we're talking about. And so the concept here is, if you look at that, it's 7 over 12, right? 712. So it's got the vertical number is on top, and then the horizontal number is on the bottom. And we're going to give this a name, all right? And I'm gonna switch colors here. We're going to give this a name, and what we're going to do is we're going to call this rise. So in other words, how much it goes up and down divided by the run. And the run is its horizontal distance. So it's vertical divided by the horizontal change, all right? And then another way they'll write this is, if you think about a Cartesian graph, right? Our vertical distance is marked by y. Our horizontal is marked by x. And so they say the rise, so that would be how much does it change in x. And so they use this triangle to show change. All right? So this means your change in your y. Sorry, I said x, didn't I? I meant y. So this means your change in your y, which is your vertical, divided by your change in your x, which is your horizontal. So you're going to start doing a bunch of problems where you're going to numerically quantify different slopes and look at them. And we're going to talk about positive and negative slope and what that means. But this is the basic concept. And the thing you're going to hear me and every other math teacher in the world talk about all the time is this whole thing of rise over run. Rise over run. So how much does it go up or down divided by how much does it go over? All right, so that's your basic introduction to what slope is. All right, slope is a numerical way for anybody to describe how quickly or slowly and in what direction something rises. Okay, so hopefully that helps a little bit with what we're doing next, and I will see you shortly, with the next video.